that was messed up.
Really smart. Chandler, Matt. Okay, so we're working with common logarithms today. So you actually get to use that log button on your calculator.
So is this going to be like easy? So it's just typing in on my calculator.
Most of it, no, but some of it. Yes. Okay, so common logarithms are with a base of 10.
Why are they this now?
Because it wouldn't make any sense if we did it before. Okay, so common logarithms have a base of 10. You can write it so that we have the 10 base written right here. But most times, if they write it with nothing, it's just log of x. It's an understood 10. It's kind of like when we have 1x, usually we just write it as x, and we don't write that 1 in there. It's understood. Okay, so it's an understood 10 because there's nothing there. All right, so example 1 says, use your calculator to evaluate each expression to the nearest 10,000. Okay, 10,000 means how many decimal places? 4 places. All right, so use the log button on your calculator to figure out what log of 5 is.
I have huge questions on my
Have you typed the number and then push log?
Probably.
No, you're typing a log. I got 0.69.
I got
89. 700. Did I sound like a really here? You sound really happy.
Matt, are you excited for the vision back?
Yeah.
That's hard.
Yeah, you are. You don't.
It's hard in the
The only thing I'm excited
So
about.
other than going to log enter, then laws.
All right, Taylor, where's your calculator?
What do I type in log 5?
Hey, is this right?
Yes.
0.6.
I'm the smartest man alive.
All right.
Actually, be.
Yeah.
All right. If you got it,
Do you round?
it says 4 places.
Okay.
4 places. So you're going to say 0.6990. Do you want 4 places? Yes, I know the 0 at the end doesn't affect anything, but they do want the four numbers. Okay, what'd you get for B?
-5 to, -0.5 to 2.8. This is wonderful.
How about this C? What would you get? 229? Oh, it is. Let's get it rounded up.
So are there like 20 problems of the center assignment?
Yes.
There's a couple, but there's not. Okay? Point, what on this one?
8.45.
845. Alright, so now that you know how to use your calculator with the next log, remember it only works if you have a base of 10. If it's not a base of 10, you can't.
I know.
Because it will say base of 10, or it doesn't have any base at all. It's an understood 10. That's how you know. Okay, so remember that the logarithm is an exponent, so we know that if we're saying if I have log of A is equal to B, that means 10 to the exponent of B is equal to A. Okay, because if we were going to write it in exponential form, remember we have base of 10, 10 is equal to the exponent, B equals A. Alright, so if we have log 1 is equal to 0, because in order to get 1, anything with a 0 power is 1. Same with this one is equal to 1, log of 10, because 10 to the 1 is 10. So if we have anything, log of anything with a 10 to the something, we'll get you 10. Questions on how those orders? Just remember it's always equal to the exponent. Okay. Common logarithms are used in measurement of sound. Sound or soft recorded music is about 36 decibels.
What's soft?
Like nice, not like
Not like Ozzy.
yeah, like elevator music, yeah. Like elevator.
Elevator
Yep.
is fun.
All right, so it tells us the loudness L in decibels of a sound is equal to this. Enough. Where I is the intensity of sound, and is the minimum intensity of sound detected by the human ear. Okay, there's an excluding several miles from a concert venue can hear the music at an intensity of 66.6 decibels. How many times the minimum intensity of sound intelligible by the human ear was the sound if little n is defined to be 1.
666.
Yeah, 66.6. Yeah.
Damn it.
Alright, so where are we going to put the 66.6? What variable is it? It's L. Good. And they tell us that they tell us that M is 1. So we're going to look for I. They want to know the intensity. How many times the minimum intensity. Okay, so we're just going to plug in. So L is 66.6 equals 10 times the log of 1 over M is 1. I over N. Okay, so since I'm dividing by 1, it's 80. Because it's all the same as
So you put in the log, it is automatically log, right?
Right, if there's no base here, it's an understood 10.
Okay.
Yep. So you need to get the log by itself before you plug it into your calculator. So I would divide by 10 to get rid of this 10. So that's equal to the log of I. Because, yeah, you can put it over 1, but it's not going to affect anything. Okay, now what are we going to do? Divide by I. Because this number is 1 whole unit, you cannot break that apart.
What is 1 to
6.66 equals I.
Equal I.
Oh, we have to rewrite.
If this log equals the exponent, and then the base is 10, so you take an exponential form of 12.
Right. Yep, exponential form. This is understood 10. So 10 is our base. Our exponent is 6.66 equals.
How is it an understood 10?
Because we said if it doesn't have any base, it's an understood 10.
Ah.
Just like it's an understood 1, x.
Okay.
Alright, so now what happens? What is 10 to the 6.66?
Wait, how did you get 10 from 666? Yes!
Base is 10.
You brought it over to the other side.
I just
4, 5, 7.
Where is this stand right?
8, 1. That's a big number. Point.
Very
about
good.
Hey,
Count up to the nearest.
How was
yeah, next one.
Jeanette is
I don't know.
There's
Jeanette.
method in mind.
Yeah, isn't it 82?
Oh, it is an 82.
Alright, that's pretty easy if they just give you a formula. You have to
Wait, what does that say? Times the.
Times the minimum intensity.
what people want.
Because that's what they're saying. How many times the minimum intensity of sound? This is how many times.
Okay.
So that's loud. Even if they are several miles away from the concert, it's still pretty loud. Ugh, I wouldn't like it there. Alright, now let's look at this next one. It says amount of energy E in, I think you call it herbs. I'm not sure, is that how you say that? Herbs? That's what it looks like to me. That an earthquake releases is related to its Richter scale magnitude M by this equation. Use the equation to find the amount of energy released by the 2004 Sumatran earthquake, which measured 9.0 on a Richter scale and led to a tsunami.
I remember that.
Alright, so we're going to plug stuff in. What is 9.0? What are we going to put that in for? What variable? M.
That's really easy.
Okay, so we've got log of E equal 11.8 plus 1.5 times 9.
I like this.
Good. Alright, so we just simplify on the right, multiply, and then add. What is it equal to? Alright. Alright, now what are we going to do?
Understood 10.
Understood 10 to the
Okay.
equals E. So then just use your calculator.
So how would I do? I'll just do 10 to be carrot.
Yep.
hold on, don't tell me anyone.
I got it. I got.
No. I got one.
Yeah, your calculator may or may not like it.
Nah.
I found this way.
My calculator says about 2 times 10 to the 25th power.
Yeah.
Yeah.
What? How did you get that?
Okay? It's about this. It's not because you have all the 999.
So there's
I was at 1.9.
That's the calculator tells me.
2 and then.
I see it.
So that means this means 25 zeros. So it's about 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 21, 22, 23, 24, 25.
Can we do that on our paper?
Do you want to?
No.
That's how many herbs it is.
So then, so when you have this, you just round it to the greatest like whole number, or like you round it and then just say times 10 to however many this is.
Yep. All right, any questions on the front? All right. All right.
How often do I change this in the place?
How often do I change it? Every holiday season. So now it's Easter time, so I put up some pretty pinky people ones. Okay, Chandler, math. I did math. That's enough. Chandler, that's enough. I have to tell you again, I'm going to sit you in the hallway, and then I'm going to make you come in after school. It's not enough. Alright, so, if both sides of an exponential equation cannot be easily written as a power of the same base, we can solve it by taking a logarithm of each side. Alright, notice, if I'm trying to figure out this, normally we would just say maybe, well, let's try 4 squared. Well, 4 squared is 16, that's not 19. Well, if I say 4 to the third, that's definitely over 19. So I know it's something in between, but I don't know exactly what that number is. Follow me?
You know what the third is?
Anybody know what the third? Well, what is
64.
64?
Oh.
Which is way, way above 19. So I know it's going to be close to 2. I'm assuming it's going to be a 2 point something to get there. Okay? In order to figure out what that is, we can take the log of both sides. I'm going to say the log of 4 to the x equals the log of 19. Okay, now thinking about our properties that we talked about yesterday, if I have something with an exponent here, how can I rewrite it? What can I do with that exponent on the outside? Right. Bring it out and multiply. So I have x times log of 4 equals log of 19. Now remember that this is one thing that you cannot break apart, and this is one thing you cannot break apart. However, I'm multiplying, right? I'm saying x times the log of 4. How can I move it to the other side? Divide it. So I'm going to say x is equal to log of 19 divided by log of 4, which you can now plug into your calculator because they're both base 10s.
How?
How what?
Are you going to divide 19 by 4 first? Or
Nope, no.
Or should I find each one separately?
Find the log of 19 and then divide by the log of 4. I would put this down
Bingo.
in parentheses. Why is it divide? Because here, remember, we pulled this out and said we're multiplying, right? So we have x times this. Oh, so I'm just dividing to move it, okay. All right, use your calculator.
2.1240.
Yep. X is about 2.123. Or does it say? It says here's 10,000. So we've rounded up to a 4 right there. Okay, this tells me if you want to check your answer, we can go back up here and figure out what is 4 to the 2.1240. Since we've rounded, it's not going to give you exactly 19, but it's going to get really awfully close. close. So let's try that.
19.00095466.
So it gets really, really close. All right, any questions on what we just did?
No.
Okay, how about on B? What are you going to do there?
Same thing.
Same thing. So we would say take the log of both sides. Since we have this exponent, I can bring it out to the outside. And then since I'm multiplying here, I can just divide. And then you can plug it into your calculator.
That makes sense.
Yeah. All right, so what did you get for your log or for your x on this guy?
2.464. 2.4650.
Got it. All right, do we need to do the last example? No. Okay. All right. So we can do the same idea, only in this case down here, we're working with inequalities. So instead of an equal sign, we just have a greater than or less than. But we do exactly the same idea. Since I have exponents, I would take the log of both sides.
Okay, but why can't we just use 5? Oh, wait.
Yeah, why can't we just say 5x
Because
cubed
we
with
don't have
1?
the same base.
Right, we're not the same base. Okay, after we write log on both sides, now what?
Let's pull out the 5y and put it in front and do the same for the other.
Okay, make sure that the y minus 2 is in parentheses because I'm pointing out that whole thing. Okay, so now, since we have a y here and a y here, somehow we're going to have to try and get them on the same side, correct? But right now he's in parentheses on the right side, so I cannot just move
Why
him
did
over.
you put in the log 3 in front of the 3?
Because I'm just taking the log of both sides.
Would you Oh, I did.
Or I'm just taking the log of both sides. I'm putting the log in front.
Track line and
Track line and 2. Not quite. Because I'm taking both of these times the log of 7. Okay? So what we're going to do is we're going to distribute over here. So I would have y times the log of 7 minus 2 times the log of 7.
Same one, same one.
Okay, I'm just distributing. Okay, it's like I have this. It's like I'm taking it times 7, so I'm just taking each thing times 7, but in this case it's the log of 7. Follow me?
Oh, yeah.
Okay, alright, so now here's a y, here's a y. We need to be on the same side. So how can I move this guy over here? What did it do? No, not divide. Minus, subtract. Yeah, because I'm going to move him over so by subtraction.
Isn't it being multiplied?
yeah.
I'm moving the whole thing over.
Oh.
Y and log of 7.
Oh, I didn't know you were doing that.
Okay, now, I want you to watch really carefully because this is where some people get really confused and lost. Notice I have a y here and a y here. I'm multiplying it by both things, so I can undistribute it. I can factor out a y, so I'm going to pull the y on the outside and take everything left in parentheses. Okay, so I'm undistributing the y, I'm factoring him out. Because if we were going to go back and multiply y, I get back to where we started. Right above that step. Does this make sense? No. Okay. Alright, so now that we have y all by itself over here, how are we going to get that stuff over there? Divide.
So we have to do that next time because I don't have any more.
So we're dividing by 5 log 3 minus log 7. And since y is all by itself, now you can plug in everything in your calculator. Be very, 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 very careful on how you plug it into your calculator. I would put everything in the bottom in parentheses to make sure that you are dividing by that whole thing.
So you take 5 times the log of 3?
Right. Depending on how your calculator works, I would find log of 3 times 5.
Okay.
Okay, so plug it into your calculator, hopefully you plug it in correctly. Again, put parentheses around stuff at the bottom. What if you, oh, I get it. Should you put the parentheses around the bottom?
Okay, because my calculator is lower than yours. 7 log. Yep. And then divide it. 3 log minus 7 log minus 5 minus 5 minus 3.
Okay. How do we go? 7 log minus 2 divided by double 7 this piece. And then double. Oh my god, it's a big sum. 5 close parentheses minus 8. Alright, do you want to do B? Have you guys got it?
We got it.
Alright. Last thing, change of base. Okay? This allows us to write equivalent logarithmic expressions that have different bases. In other words, you can take something that has a different base other than 10 and write it so it has a base of 10, so you can actually put it in your calculator. Okay? So, here's our log base changing formula here. Okay? If we start off with something like this, actually it's probably easier to look at the numbers down here. Okay? Let's say we had a log base of 3 of 11, and I wanted to be able to type in your calculator so that we needed a base of 10. So we would write the log base of 10. Notice they're both 10 because that's what I'm changing it to. And then I put this 11 on the top, and this is a 3 on the bottom. Okay, it'll make more sense when we do an example with it here. Okay, so it says express the log in terms of common logarithm, meaning they want you to have a base of 10, and then round to the nearest to 10,000. So I would write it log, we want to change it to 10, so I'm going to put 10 in there. I'm going to put the 10 in there just to remind myself that's what I'm changing it to.
So it's just log 3 over log 3.
Yeah.
So then you just have it in your calculator. So 21. You should come up with. Okay, do you want to do the last one or you got it? No.
Got it. I'm actually understanding math this time around.